Hi everyone. I'm going to try to entertain you for the next 20 minutes. And since I'm not looking at you directly, this is a very new format for me. I'm going to try something new. So raise your hand in the chat if you're not wearing pajamas. I'm going to start. This guy here, his name is Willy, and he's a llama. He's going to be the representative of the audience. I'm going to sit him right here where I'm looking at you guys and gals and everyone else, and we're ready to start. Oh, I see a lot of people not wearing their pajamas. That's good for working from home. And I'm going to talk about some fun we can have with async hooks and stack traces and some monkey patching. This is going to be quite node specific, but it's aimed to be more fun than education. We'll see how it goes. I dubbed it nerdy amusement. And if you want to follow through, if you want to click some links, you can go to my website. It's linked there already. You can also download the repository of the examples and fiddle with them, hopefully while still watching what I'm doing. But it's also choose your own adventure type of thing. Stuff's documented partially. So yeah, let's go. I hope this is gonna look a bit like the TED Talk from Clifford Stoll. If you haven't seen it, the image is actually a link. I recommend looking at that after you've finished with our 24-hour conference. But yeah, if everything goes well, it's going to be as fun and as chaotic. I can guarantee the chaotic part. Not sure about the fun. We'll see about that. So in my daily work, I run a team that builds apps with Node.js. We're building integrations, tools, and applications, and there's something like 30 of them already. It's been a few years, but I also have some unusual hobbies, and what I'm going to talk about here is not at all work-related. For me, it's my hobby. One of my hobbies is collecting metal covers of pop songs and anything famous, actually. So if you want Hakuna Matata with some drums and growling, you bet I have it. But I also have a different hobby that is lurking around the diagnostics working group, trying to understand what the group is doing and contributing some documentation every now and then. So here's what I've tried to do as part of that hobby. So I always liked trying seemingly impossible things in JavaScript. And async hooks, when they showed up, they promised me that, and I explored. But first, before we go into the gory details of what weird things you can do with async hooks, I want to tell you something about those hooks to begin with. So yes, intro. Async hooks showed up sometime in Node 11. They stabilized a bit in Node 12. They're still experimental. So anything you see here, this is not for production unless you're really desperate. Async hooks are working fine in Node 12. There's some changes going on still, so the API is still unstable. Some of the fun things I'm going to show you don't use the full API because it didn't exist at the time yet. I think I'm going to mention that. So what are async hooks? This bit of code is how you create one. So you take the built-in async hooks module, you run the create hook function with some callbacks in it, before, after, and destroy. These are the basic ones. And then you enable it. For performance reasons, you can enable, disable the hook instead of running it all the time, because there's penalty to running hooks, as anything that's gonna swoop in and act on every bit of functionality you have. This is gonna have some performance penalty. Incredible work has been done to limit that and to make it lower. So it's worth the trade-off, I would say. So this is going to be a bit of a hand-wavy explanation of what the callbacks are. literally hand wavy. So if you look at the wavy emoji, this is about the moment when the init callback is going to fire for the function that we're seeing. So when the asynchronous resource, a promise in this case, is being created by the then function, and it's the function that we're looking at, the arrow function here, is being assigned as the continuation for fulfillment. That's when the init callback happens. And what's great about it is that it's happening in the current call stack. So you can get a stack trace. Spoiler alert, we're gonna use that. There's a before callback that's running, obviously, before the function that's been registered on the promise. Then there's the after callback that runs after the current function finishes. And between those, there's only synchronous work happening. Unless, okay, there's a tiny asterisk. As far as I know, async hooks are not covering 100% of cases where something is synchronous yet. They're very close to 100, but some more involved people would have to tell you what exact quirks you can see live. Maybe it's already covered in Node 13. I didn't have a chance to look it up, so I'm being honest here. And the destroy callback, and that happens sometime after the whole thing, and you don't really know. Well, you do know it's deterministic, but it's not something you can easily establish when looking at the code. Like if you want to run the destroy callback and then something else in the code, making sure that they run in a specific order. It's possible, but you shouldn't try that, and you shouldn't depend on that. This is instrumentation. Let's not mix it with logic, right? Yeah, that got too far. There's also promise resolve, which is a newer callback on the list. And I only have 20 minutes, so I'm not going to tell you about it. Let's head on to the experiments that I wanted to show you. So for the experiments, I'm going to go through a few things that I've been playing with. These are related to diagnosing what your app is doing one way or another. So yeah, without further ado, let's get it started. Have you ever wondered how many promise objects a bit of code is actually producing? So if you're running some logic and doing .then.catch, how many promises are created there? Or if you're looping and creating promises, is there a way to measure it? Well, yep, async hooks. Let's look at an example. This is an example that came up in some training I did last year. Imagine an array of functions that could be synchronous or asynchronous functions. They should work the same regardless. And then you want to compose them with a reduce. So here you have an example first where you use async await to compose them. And then you have the reduce with .then, the old school way. It's funny how promises are now old school. These are the numbers, surprisingly. I recall we spent some time counting those, and we came to similar numbers in our heads, but this is coming from a program that's using it. So yeah, there's a difference, and you should be aware that that this might indicate different performance. I'm not claiming it is. You would have to benchmark it, but this is a nice hint. And okay, let's get into the code, and I'm going to show you how I did this. It's surprisingly short. This is the whole thing. And it's one of the tools in the tool belt I'm going to show you later, but it's small enough to fit on the slide. So let's take a look. We're creating a hook, and we're only passing init callback, nothing else. And the second argument to init callback is the type of the resource that's being created. So if you happen to know what the possible value there is, one of the values is promise uppercase, you can check for it. And we're literally counting every time the hook claims that a new promise resource was created. We enable the hook, and on before exit is another fun thing that's available in Node that no one really considers because you rarely need it. Yep, you can log out some text when the program finishes without really digging into the program's code itself. So now put your code that you want to measure in a file, require this, and run. And we're good. I can demo that. How are we on time? Yeah, maybe later. Because there is more fun in the debugging aid package. So I put all those experiments in the package, so it's easy to install and try it out. It's on NPM, and it's looking something like this. So there's a bunch of tools, and we're gonna see a few of them, and you can -- require any of those. Yep. Okay, next. This is the Holy Grail, my personal Holy Grail, and I've been looking for a way to find out which function is blocking the event loop exactly. Ever since I discovered that, hey, there's a tool that can notice when the event loop gets blocked without actually having to go to the API endpoint and seeing that it doesn't respond. So yeah, there's a lot of tools that let you detect that the event loop is blocked. Let's see how we do it with async hooks. I think that was predictable. We get the before and the after. We take the time. Please don't use date now, actually. This is just pseudocode. And we're taking async ID. Async ID is the ID of the async operation, or more precisely, the resource behind it. And both callbacks are going to get the same async ID for this thing we're running. So we can save the exact time when the before hook was called, then save the time when after hook was called, take a delta, and see if it isn't too big, right? Okay. But I told you we can find out which function exactly, right? Yeah, we can. So don't know if you knew, you can do error.capture Stacktrace, which is a fun thing that decorates any object with the stack property that's going to contain the current stack trace. It's not for free, but if you do some magic parsing, you can get the actual line when the declaration of the asynchronous resource happened. And that's something that deserves a demo. So I'm going to show you what it's like. Block.dat is doing exactly that. Let's take a look at the examples. Yeah, this. Okay, boom, right here. So I have a demo, and the demo consists of running the right command on a test case of sorts. So this is the code for the test case. So we have a bunch of promises nested and chained in different ways to represent a complicated program. They're not doing anything useful, but they're there and they're complicated. And we have a slow function, the most naive slow function imaginable. This is a while loop that takes a while. Pun intended. Sorry for that. And we can run a tool Oh, oopsie. Right, we can run a tool that's going to do a fun thing. So we're running node required, debugging aid blocked, and running this on our code. And this is going to show our code is printing slow and the time that the function claims it took. So between the beginning and the end of the while loop. And now this tool detected that the block time was a bit larger, and then it gives us a stack that points to the file with the actual place where it happened, and we can click on that, and it shows you that, hey, this is the line where the function was declared that did something that took 100 milliseconds of the event loop life, right? And the same for the other case. So it found both of them, and it's pointing to the start function. So this one as the function on the stack, because when this was created, the resource was created, this was the function that was on the stack, and this was the line that was being executed. So you wonder, how did that happen? Well, it's here. There's going to be a bit more code than you would expect for the examples I've shown you, because there's a lot of other things you need to consider. But hey, there's the init callback, and it captures a stack trace and puts it along with some other information in some sort of cache that we're using in the before and after calls. We clean it up on destroy. That's important. And we know that we can use this stack and show it to the user or give it back to the program whenever interesting things happen, which is going over a threshold that was set. Right? So back to the slides. You can review this file as well. The link in the presentation leads there. Okay. So can we see which modules are using the network? Well, yes, there is a tiny tool in debugging aid that does exactly that. You can see that there was a request to example.com coming from this stack, and this stack is a bit of internals and then requests. So we know that it's our lovely slightly deprecated request dependency that's making this call. That's great. And bonus, the same way you can protect your app from going overboard and starting downloading stuff from packages you didn't expect. I wrapped it around in package firewall. This is using some silly monkey patching. I recommend you take a look at it. I'm actually checking if the net module is requested from the module cache of Node, and then also capturing a stack trace and parsing it and finding out which dependency is trying to get it. It's fun. It's not usable ever since import is there, so I'm going to add some logic to handle imports as well. And the last bit is, can I visualize a synchronous flow of my application? Well, there's definitely better tools for that. So I'm competing with NearForm a bit in here with this silly experiment, I guess. Yeah, but this is the last demo. You can run a tool. It's also in the examples. So if you run the hooks command, I could actually run it right now. cmd hooks. I'm almost done. Yeah, so this produces some output. This output is less useful than the file it produces. So it hacks the trace events to produce a trace file. And if you load it to Chromium, I'm going to skip right into it. You're getting a visualization of the time it took and all the promises and everything. So you can see that promise line 10, the same line that we saw before, is taking this much time, and you can explore this. I never know how to operate this. You can zoom in and you can select another one. So this is the duration of the previous promise, and then this is the duration of this promise. And all this is done with almost no code. So that's going to be the last thing I'm going to show you, debugging aid, the hooks implementation here. This is the whole implementation. And it's producing the console output, and it's getting Node to produce the thing you can visualize. And yeah, that's all the fun I had. Thanks for participating in my silly hobbies. I'm Magtur. If you type that anywhere on the web, it's me that you will find. Thanks for watching. I hope you had fun. I hoped someone learned something new or got inspired. Thanks for listening, and I'll see you later.